Hello everybody, welcome to Math Mastery. My name is Tanvi and today I am going to discuss a few important long answer, short answer questions as well as numericals of chapter 6 of class 11 statistics book. The name of the chapter is correlation. The questions that I am going to discuss are question number 7, question number 9, question number 17 and 18 of the exercise of chapter 6. Question number 7. Why is R preferred to covariance as a measure of association? So here R means coefficient of correlation. So first we have to understand what is covariance and what is coefficient of correlation and what is the difference between the two. So covariance is also measures the direction as well as intensity of association between the two variables. The formula to calculate covariance is summation x minus x bar multiplied by y minus y bar divided by n. Whereas the coefficient of correlation, the formula to calculate R is covariance divided by standard deviation of x multiplied by standard deviation of y. So the advantage of R over covariance is that the value of R ranges between -1 to +1. So therefore it is very easy to interpret that value. For example, if the value of R is 0.25, so it means that the relationship between the two variables is positive but weak, whereas if the value of R is 0.89, then it means that the relationship is positive, whereas as well as the relationship between the two variables is strong. So if the value of R is close to 1, then it means the relationship is strong, whereas if the value of R is close to 0, it means the relationship between the two variables is weak. Also, if there are 2 or 3 different data sets, then it is very easy to compare the value of R across different data sets. Whereas in covariance, there is no such standardized value. The value of covariance can be anything. It doesn't range between -1 to +1. It can also be 100 or any other value. Okay. Another property of R is that the magnitude of R is unaffected by change in origin and scale. This means that if the variable x and y are very large values, okay, let's say the value of variable x is varying from 1100 to 1200, 300 and so on. Similarly, value of variable y is also very big. For example, it's 100, 200, 500, 700 and so on. So in that case we can change the origin as well as scale of that variable using step deviation method, and then we can calculate coefficient of correlation by using the modified variables u and v. So therefore it is a very good and interesting property of R that it is unaffected by change in origin and scale. Okay, so that is why R is preferred to covariance as a measure of association. Does correlation imply causation? So what is correlation? Correlation measures the direction and intensity of association between the two variables. For example, if we are talking about income and consumption, let's say income and consumption are two variables. So correlation explains that whether the change in income is related to change in consumption or not. Also, it tells us whether the change in income is positively related to change in consumption or not. Okay, but this correlation does not tell us whether the change in income causes change in consumption or change in consumption causes change in income. This is explained by regression. Okay, so causation basically means when one variable is the cause and the other variable is effect. In order to understand that, we need to regress one variable on the other variable, which comes under the regression. Okay, regression helps us to know that the change in income leads to change in the consumption. So therefore correlation does not imply causation. Question number 17. Why does rank correlation coefficient differ from Pearsonian correlation coefficient? So we have studied Spearman's rank correlation as well as Carl Pearson's coefficient of correlation to calculate coefficient of correlation. So there is a difference between the two methods. It is important to understand the difference in order to know when to use which method to calculate coefficient of correlation. So number one, Pearsonian correlation coefficient is used when there is linear association of variables, whereas rank correlation coefficient is used when there is linear or non-linear association between the two variables. So if the variables are not linearly related, in that case we assign ranks to those variables and then we use those ranks to calculate rank correlation coefficient. Number two, it is used when variable is quantitative and data values are given. So rank correlation coefficient is used when the variable is quantitative, whereas, Pearsonian correlation coefficient is used when the variable is quantitative, whereas rank correlation coefficient is used when the variable is both quantitative as well as qualitative in nature. So if the variable is qualitative in nature, such as if there is a variable like beauty, honesty, etc., then we can rank that variable with the help of a certain criteria, and then we can use those ranks to calculate the coefficient of correlation. And even if the data is quantitative in nature, then we can assign ranks to those quantities in increasing or decreasing order in an order such that that order is uniform for both the variables x and y, and then we can use those ranks to calculate coefficient of correlation. So it is used when variable is both quantitative and qualitative. Number three, the Pearsonian correlation coefficient gets affected by extreme data values. Why? Because we are using the exact data values to calculate the coefficient of correlation. Whereas rank correlation coefficient does not get affected by extreme data values. So whenever the data values are extreme, so we can use rank correlation coefficient method. Number 4, it gives precise answer when data values are given, because the exact data values are used to calculate the coefficient of correlation in Carl-Pearson method. Whereas in rank correlation coefficient, the data values are first converted into ranks, and those ranks are used to calculate coefficient of correlation. So therefore, it will not be as precise as Pearsonian correlation coefficient when data values are given. So I hope this is clear. With this, I move to the next question. Question number 18. Calculate the correlation coefficient between the height of father in inches and their son in inches. So there are variable x, which is the height of the father, and variable y, which is the height of a son. So as you can see that the values are quantitative and exact and precise values are given to us. So therefore, the Carl Pearson's method of calculating coefficient of correlation is better than Spearman's rank method. So we will use Carl Pearson's method of coefficient of correlation. So now you can see that I have calculated coefficient of correlation using this formula, and the value of coefficient of correlation R comes out equal to 0.4375. So what can we conclude? We can conclude that the height of the father and height of the sons are positively related. However, the relationship is not very strong, or it is a weak relation, because the value is not close to 1. Okay. So with this, I have completed this chapter 6 of correlation. I will start with the next chapter, indexation, in my next video. Thank you.